Hey y'all, today is May 18th and we are going over your test number 8 study guide. This is your test on geometry, so grab your study guide and pay attention and let's get started. So the first topic you're going to see on your test is scale drawings. You'll see 3 questions and they will be 4 points each. So let's go ahead and get started with some review. So number 1, a bobblehead of Steph Curry uses the scale of 1 centimeter equals 4 inches. If he is 74 inches tall in real life, how tall is the bobblehead? Okay, so important information here. We know that 1 centimeter equals 4 inches. So I'm going to use that for the first fraction of my proportion. So 1 centimeter over 4 inches. And the reason I include the units here is because I know in my second fraction, I'm going to need the centimeters on top and the inches on the bottom. So remember, we're writing a proportion, so 2 fractions that equal to each other. And the only other piece of information that's important to me is that he is 74 inches tall in real life. So because I know where inches go, they go on the bottom, I know to put the 74 down here and I'll put the x on top. Now I just cross multiply. So 4 times x is 4x. And I set that equal to 1 times 74, which is 74. To get that x by itself, all I have to do is divide by 4 on both sides. So x equals 18.5. 18.5 centimeters. Don't forget to include your unit. Okay. Moving on to number 2. The blueprint of a house has a scale of 2 inches equals 9 feet. The scale drawing is shown to the right. What is the actual length of the house? Okay, so here's our scale drawing right here. So we see our scale drawing right here. What I would consider is the length is this one here, and I would consider 9 the width, okay? So when it says what is the actual length of the house, I'm focused on this right there, okay? Now, we know that the blueprint has a scale of 2 inches equals 9 feet. I'm going to use that information for my first fraction. So 2 inches over 9 feet. And I set that equal to another fraction. And because I include the units here, I know that I would need inches on top and feet on the bottom, okay? Well, my length, what I'm concerned about right here, is 15 inches. So I know I'm going to put it on top, so 15 goes on top, and my x goes on the bottom. And now I'm just going to cross multiply. So we have 2 times x, which is 2x, equals 15 times 9, and 15 times 9 is 135. Now to get that x by itself, I'm just going to divide by 2, and I'll do that on both sides. My 2's cancel out. X is by itself. 135 divided by 2 is 67.5. 67.5 what? Well, because my unit feet was on the bottom, I know it has to be feet. So the actual length of the house is 67.5 feet. Okay, moving on to number 3. The scale on a map reads 1/2 inch equals 40 miles. If 2 cities on the map are 4 1/4 inches apart, find the actual distance between the cities. Okay, so we're still doing scale drawing, so I know I'm going to use this information right here to write my first fraction. Now, I don't really like fractions and fractions. So what can I do with this 1/2 so that I don't have a fraction inside of a fraction? I can make it 0.5. That's exactly what I'm going to do. So we're going to have 0.5 inches over 40 miles. Okay, this tells me that I need inches on top and miles on the bottom. So let's see what else we were given. We know that 2 cities on the map are 4 1/4 inches apart. So I know that needs to go on the top, but again, that mixed number is like a fraction inside of a fraction. I don't like that. So I know my whole number piece is 4. What decimal would I use for the 1/4? 0.25. So 4.25 is equivalent to 4 1/4. So that's what I'm going to use. So we have 4.25 inches, and we're trying to figure out the actual distance between them. So now I'm ready to cross multiply. 0.5 times x is 0.5x, and then 40 times 4.25, when I put that into my calculator, I get 170. So now I'm ready to get that x by itself. It's connected to 0.5 through multiplication, so we're going to divide by 0.5 on both sides. That cancels out. X is by itself. And 170 divided by 0.5 is 340. 340 what? 340 miles. Okay. Let's move on to our second topic. Our second topic is triangles. There will be 3 questions, and they will be 4 points each. So number 4, a triangle has angle measurements of 95 degrees, 42 degrees, and 43 degrees. What kind of triangle is it? So we are classifying this triangle on these 3 angle measurements, 95 degrees, 42 degrees, and 43 degrees. And the one angle measurement that stands out is this 95-degree angle measurement. So when I have one angle that is greater than 95 degrees, I know I have an obtuse triangle. So some vocab that you will need to know to be able to answer a question like this. You will need to know what an acute triangle is. That means all 3 angle measurements are less than 90 degrees. You will need to know what a right triangle is. A right triangle has one angle that is exactly 90 degrees, one angle that equals 90 degrees. And lastly, you will need to know what an obtuse triangle is. An obtuse triangle has one angle measurement that is greater than 90 degrees. Okay, so that is some helpful vocab for a question like number 4 on your test tomorrow. Okay. Let's move on to number 5. Find the value of x. Okay, well, we know that one angle measurement is 67 degrees. And we have this one is labeled as x, and then this one isn't labeled at all. But this square right here is really important. When I see a square inside of an angle, I know that that's a right angle. So I know that that angle is exactly 90 degrees. So now all of a sudden, I have 2 known angle measurements and just one unknown. And I'm trying to find the unknown. So remember, all 3 angles have to add up to equal 180 degrees. So I'm just going to write an equation. So we have 67 plus 90 plus x equals 180 degrees. Okay, now I'm just going to combine some like terms. And my like terms here are 67 and 90. And when I combine those, when I put that in my calculator, I get 157. So 157 plus x equals 180. Now this right here is a normal one-step equation. To solve for x, we're just going to subtract 157 on both sides. So on the side with the x, 157 cancels out. X is by itself. And on the other side, 180 minus 157 is 23. So I know that x equals 23 degrees. Okay, let's move on to number 6. So this one is the same concept as number 5, but just a little trickier because we have some algebraic expressions. So we're solving for x. Okay, so I know that one angle measurement is 66 degrees, one is 5x minus 24 degrees, and one is 2x plus 5 degrees. So I'm just going to add all of these together and set it equal to 180 to solve for x. So we have 66 plus 5x minus 24 plus 2x plus 5. And again, we set that equal to 180. Now let's combine some like terms. So some like terms that I have. Let's start with our x terms. I have 5x plus 2x. And 5x plus 2x is 7x. So we have 7x. And now all the numbers, 66, negative 24, and 5 can all be combined. And when I put 66 minus 24 plus 5 into my calculator, I get positive 47. And now I just set that equal to 180. Okay, so now this is a normal two-step equation that I know how to solve. I'm going to start by subtracting 47 on both sides of my equal sign. 47 cancels out and 7x is by itself. On the other side, 180 minus 47 is 133. Now to get that x by itself, I just have to divide by 7 on both sides. And when I do that, x equals 19. Okay. So now let's move on to our third topic. Our third topic is angle relationships. You can expect to see 3 questions on this topic, and they will be 4 points each. So number 7, what is the value of x? What is the measure of angle AZB? And what is the measure of angle BZD? Okay, so we've got 3 questions that we have to answer here. The first one is, what is the value of x? So what I see in this image is I see an angle here, a second angle here, and a third angle here. So I see 3 angles. And I also see that they all lie along that straight line. So all together, they add up to 180 degrees. They make a straight angle, right? Okay. I also see this box right here telling me that there's something really special about that angle. That box tells me that that angle is 90 degrees. So now all of a sudden, I have 2 angles that are given to me. Their measurements are given to me. This one here is 90 degrees, and this one here is 45 degrees. Now, to find the value of x, let's talk about just this side over here. If the other side, this side here, has that square, and I know it's 90 degrees, what do I know about this side? Well, it's also 90 degrees, because 90 plus 90 is 180. So can I use this information here to write an equation to solve for x? Yes, I can. So that would look like 45 plus 5x equals 90. Because like I said, we know that these 2 angles have to add up to 90 degrees. They have to be complementary, right? So now I'm just going to solve this like a normal 2-step equation. I'm trying to get that x by itself, so I'm going to subtract 45 on both sides. So 5x equals 45. Then I'm going to divide by 5 on both sides. And when I do that, I find that x equals 9. So x equals 9 is the answer to our first question. Okay, now what is the measure of angle AZB? Well, I need to know what angle AZB is. So AZB. So I'm talking about this 90-degree angle and this 45-degree angle, right? So how do I find the measure of all of that together? Well, I'm simply just going to add 90 plus 45. So angle AZB equals 90 degrees plus 45 degrees, and when I add that together, I get 135 degrees. So that's the answer to my second question. Okay? And lastly, what is the measure of angle BZD? Well, BZD is this angle that I don't have highlighted. It's the 5x angle, right? Well, we already know what x is. We know that x equals 9. So wouldn't it make sense to say 5 times 9 here to find the measure of that angle? Yeah, and 5 times 9 is 45 degrees. So angle BZD is 45 degrees. Okay, so we have answered all of those questions in number 7. Let's move on to number 8. What is the value of x? Well, first I need to know what kind of angles these are. And what I notice right away is that these angles lie along this straight line. Oops, let's just make that a normal line. They lie along that straight line right there, right? So because they lie along that straight line, they form a straight angle. And that means that they add up to 180 degrees. So these are supplementary angles. They add up to 180 degrees. So all I'm going to do is take this expression and add this expression to it and set it equal to 180. So we have x plus 30 plus 4x plus 5 equals 180. Now I need to know if I have any like terms. So let's start with our x's. We have x plus 4x. When I combine that, I get 5x. And then my other numbers, 30 and 5, I can also combine. That makes 35 plus 35 equals 180. So now I'm going to solve this like a normal two-step equation. So I'm going to start by subtracting 35 on both sides. 35's cancel out and 5x comes down. 180 minus 35 is 145. Now to get that x by itself, I'm just going to divide by 5 on both sides. And when I put this into my calculator, 145 divided by 5, I find that x equals 29. Okay. Let's move on to the next page, number 9. Circle the statements that are always true. So I'm looking for what is true here. So let's start with A. 2 right angles are supplementary. Well, 2 right angles means that I have 2 angles that equal 90 degrees, right? So 90 plus 90 equals 180. So I need to know this vocab term supplementary. Supplementary means that I have 2 angles that add up to equal 180 degrees. So do I have 2 angles that add up to equal 180 degrees? Yes. So I know that A right here is true. So I'm just going to highlight it instead of circling it. It's true. Okay. Now B. Given 2 vertical angles, if one is acute, the other must be acute. Okay, so I need to know about vertical angles. Well, vertical angles occur when I have 2 lines that kind of make an X like this. So I know that this angle here, angle A, angle A right here, and angle B right here are vertical angles. They are directly across from each other. And one thing I know about vertical angles is that they are congruent. So let's say that this angle A equals 75 degrees. What is the measure of angle B? Well, 75 degrees. They have the same angle measure. That's what congruent means. Vertical angles are congruent. They have the same angle measure. So I chose 75 for a reason, because it's less than 90. So that means that this top angle right here is acute. Is its vertical angle, the bottom one, the one directly across from it, is it also acute? Well, 75 is less than 90, so yes. So, given 2 vertical angles, if one is acute, the other must be acute. Yes, that is true. Let's highlight that one too. Okay, so it said to circle the statements that are true. It didn't tell us how many, so they might all be true. Let's find out. So C, if 2 angles are complementary, then one of them is a right angle. Well, if 2 angles are complementary, that means we have 2 angles that add up to equal not 180 degrees this time, but 90 degrees this time. Then one of them is a right angle. Well, a right angle is an angle that equals 90 degrees. So we're saying we have 2 angles that are complementary. They add up to equal 90 degrees. One of them is a right angle. One of them is 90 degrees. No, that's not possible. So C is not true. Okay, what about D? If 2 angles are complementary, again, that means that we have 2 angles that add up to equal 90 degrees. Then they are adjacent. Adjacent means that they are next to each other. Okay? So this could look like, let's see if I can draw this well. Okay, so it could look like this. We could have a, let's just say I drew it perfectly, and that's a 45-degree angle, and that right here is also a 45-degree angle. Okay? Now, these are adjacent angles. How do I know that they're adjacent? Well, they're right next to each other. Do I know that they're complementary? Well, 45 plus 45 equals 90. So they are complementary. But could I have them be separate? Yeah, I don't have to have my angles next to each other to make them complementary. They don't have to be adjacent in order to be complementary. Those two things don't always go together. Okay? They can, but they don't always. So I know that D is not always true. So I'm not going to highlight D. Okay? Let's move on to our fourth topic, circumference of a circle. So circumference of a circle, there are a couple of different formulas that you can use. The one that I will give you on the test is C equals 2 times pi times the radius. And I want to point out that every time you see that pi, you're going to use 3.14. Always, always, always. Okay? So now that we know our formula, let's go ahead and get started with our review on circumference. So number 10, find the circumference of the circle. Use 3.14 for pi. Well, here's a circle, and I was given one very important piece of information, 7.5 inches. Now, why is that important? Well, I know it's the radius, and I know it's the radius because that line goes from the circle edge to the center. It doesn't go all the way through the circle. So I know that this right here is a radius. So with our formula, C equals 2 times pi times the radius, I'm just going to plug that in. So we have 2 times 3.14 times 7.5. And now I'm just going to go to my calculator to find the circumference. So 2 times 3.14 times 7.5. And when I do that, I get 47.1. So the circumference is 47.1 inches. Okay, let's move on to number 11. New lights are being installed around the outside of a Ferris wheel. Lights cost $1.25 per foot. What is the total cost of the lights? Use 3.14 for pi. So new lights are being installed around the outside of the Ferris wheel. So lights are going around here. So they're going all the way around the Ferris wheel. So I am finding the circumference here. So we're going to use our formula C equals 2 times pi times the radius. And I need to know why is 60 important. Well, 60 is important because it goes from the edge to the center. So I know that that's my radius. So I'm just going to plug that into my formula. We have 2 times 3.14 times 60. So let's go to our calculator and find out what the circumference is. So 2 times 3.14 times 60. And I get 376.8. So the circumference is 376.8 feet. Now we're not done because the question being asked to us here is what is the total cost of the lights? I don't want to know what the circumference is. That's not my answer. I want to know how much it's going to cost. And I know that the lights cost $1.25 per foot. So what should I do with $1.25 and 376.8? Did you say multiply them? Because if you did, you're correct. So we take our circumference, 376.8, and we multiply it with 1.25. So let's put that in our calculator and see what we get. So I'm going to hit this answer button just to copy that answer, and I'm going to multiply that times 1.25, and I get 471. So it will cost $471 even to install those new lights around the Ferris wheel. Okay, number 12. The wheels on a car have a diameter of 32 inches. How many full revolutions will the wheels need to travel 500 feet? Use 3.14 for pi. Okay, so important information here. The wheels on a car have a diameter of 32 inches. So we need to recognize what that looks like. So I'm going to draw a picture. So we have the wheel, it's a circle, and diameter means that we measure from one edge all the way to the other edge. So 32 inches is the diameter. Now, there is a formula I can use that calls for diameter, and you are welcome to use that, but I'm going to find the radius. So I know that the diameter is 32 inches. That means the radius is half of that, and half of 32 is 16 inches. So I'm going to use radius in my formula. So the formula I'm using to find the circumference is c equals 2 times pi times the radius. So I'm just going to plug in 16 for r and solve. So we have 2 times 3.14 times 16. Okay, so let's put that into our calculator. 2 times 3.14 times 16, and I get 100.48. So 100.48 is my circumference. Now, 100.48 inches, let's include our units. Now, that wasn't the question being asked. We weren't asked to find the circumference. We were asked how many full revolutions will the wheels need to make to travel 500 feet. Okay, so how many full revolutions? What that means is how many complete turns will the wheels make to travel 500 feet? Now notice, 500 feet is a whole different unit than inches, right? So let's go ahead and convert 500 feet to inches. Well, how do I do that? Well, I know that there are 12 inches in 1 foot. So I'm going to take that 500 and I'm going to multiply it times 12. Let's put that into our calculator and find out what that is. So 500 times 12, and I get 6,000. So I know that this is 6,000 inches. So now the question is, how many full turns will the wheels make to travel 6,000 inches? So all I'm going to do is take the 6,000 inches and divide it by the 100.48 inches. So let's put that into our calculator. So 6,000 divided by 100.48, and I get 59.713, and it keeps on going, right? So we have 59.713, and that decimal just keeps on going. Now, how many full revolutions? That word full is important because that means complete revolutions. Well, 59 is not enough. So I'm actually going to need to round up. So 60 full revolutions is my answer. And I'm not just rounding up because my first place after the decimal is a 7. Even if I had had 59.2, I would still need to round up because 59 revolutions is not enough. I would need to go that extra revolution to go all 500 feet or all 6,000 inches. Okay, so now let's move on to area of a circle. So our next topic is area of a circle. So there is a formula for area of a circle that you need to know. Area equals pi times the radius squared. Area equals pi times the radius squared. Okay, so now that we know that, let's look at number 13. So find the area of the circle, use 3.14 for pi. Well, why is 5 kilometers important? Well, that line goes from the outside edge to the center. It doesn't go all the way through, so I know that that is my radius. So I'm going to use that in my formula. So area is pi times the radius squared. So that is 3.14 times 5, and I have to square that 5. Okay? So let's go put that in our calculator and find out what we get. So we have 3.14 times 5, and on this calculator, I hit that a squared button right under main to square it. And I get 78.5. So area is 78.5 kilometers squared. Don't forget your units. Anytime we're talking about area, we want to square our units. Okay? Let's move on to number 14. Now, number 14, it says find the area of the circle, use 3.14 for pi, but this time I was given a line that goes from one edge all the way through the center to the other edge. So I was given the diameter. So the diameter of this circle is 115 yards. Well, that doesn't help me for my formula. I need to know the radius. So how do I find the radius? Well, it's just half of 115. And if I find that, if I put that into my calculator, 115 divided by 2, I get 57.5. So 57.5 is my radius, and that's what I'm going to use in my area formula. So area is pi times the radius squared. So we have 3.14 times 57.5, and I have to square that. So now let's go put that into our calculator to find out what we get. So 3.14 times 57.5, and I hit that a squared button underneath main to square that, and I get 10,381.625. So 10,381.625, and my unit is square yards. Okay, let's move on to number 15. Raphael is building a circular table with a diameter of 6 feet. The wood costs $26.25 per square foot. How much will it cost Raphael to make the table? Use 3.14 for pi. So when I have a problem like this, I like to draw a picture. So he's building a circular table. So we have a circle with a diameter of 6 feet. So diameter means it goes from all the way from one edge to the other edge, sorry. And I know that that is 6 feet. Okay, now diameter doesn't come in handy in my formula, but radius does. So if my diameter is 6 feet, my radius is half of that. That means my radius is 3 feet. And I'm gonna use radius in my formula. So area is pi times the radius squared. So we have 3.14 times 3 squared. So let's go put that into our calculator to find out what the area of this table is. So 3.14 times 3 squared, and I get 28.26. So the area of this table is 28.26 square feet. Now the question is not asking what is the area of the table. The question says that the wood costs $26.25 per square foot. How much will it cost Raphael to make the table? So what do I need to do now with the 26.25 and the 28.26? Did you say multiply them? Because if you did, you're correct. So 28.26 times 26.25. Let's put that in our calculator and find out what we get. So I'm just going to copy that answer, and now I'm going to multiply that times 26.25. And I get 741.825. So 741.825. Now we're talking about money, and money doesn't have 3 decimal places, it has 2. So I've got to round it right there. And because that's a 5, I'm going to round up. So $741.83 is how much it will cost Raphael to build this table. Okay, let's move on to our next topic, cross sections. You can expect to see 3 questions, and they will each be worth 4 points each. So when I say identify the cross section, what I'm asking you to do is imagine the 3D figure being sliced either parallel or perpendicular to the base, and then we open it up. We open it up like a book, and we look inside. What shape do we see? So number 16, we're slicing this, it looks like a square pyramid, perpendicular to the base. So from top to bottom. When we open it up like a book, what shape do we see? We're going to see a triangle. Oops. Okay, number 17, identify the cross section. So here we have a cone. Okay, it's a circular base, and we're slicing it parallel to the base. We're slicing it horizontally. And anytime we slice a figure horizontally, the cross section matches the shape of the base. So here I know that my cross section is a circle. Okay. Number 18, a cylinder is sliced horizontally parallel to its base. What is the shape of the cross section? So let's think about what a cylinder is. A cylinder looks kind of like this, and I'm not an artist, but I think you get the idea, right? Okay, now it's sliced horizontally parallel to the base. Well, the base is down here and up here. It's what I have 2 of, and I have 2 circles. So we're slicing this figure parallel to the base, like that. Well, when we open it up, what shape will we see? Well, anytime we slice parallel to the base, my cross section matches the base. The base is a circle, so my cross section is a circle. Okay, let's move on to topic 7, surface area. So you will see 3 questions. They will each be worth 4 points. So let's go over surface area. So number 19, find the surface area. Well, this is a rectangular prism. So there is a formula that I can use here. So that formula is 2, That formula is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Okay, now it doesn't matter how I label my numbers as long as one of them gets to be length, one gets to be width, and one gets to be height. So let's call this one right here my length, this one right here is my width, and this one right here is my height. So we have 2 times 12 times 25 plus 2 times 12 times 10 plus 2 times 25 times 10. So now let's put some of this into our calculator and simplify. Okay, so I know that 12 times 25, when I put that into my calculator, I get 300. So here I have 2 times 300 plus, I know that 12 times 10 is 120. So 2 times 120 plus 25 times 10 is 250. 2 times 250. Okay, let's continue to simplify. 2 times 300 is 600. 2 times 120 is 240. And 2 times 250 is 500. So now all I have to do is add these 3 numbers together. 600 plus 240 plus 500 is 1,340. And my unit is square feet. So that right there is my surface area for that rectangular prism. Hold on one second, y'all. Okay, number 20. Find the surface area. Here we have a triangular prism. And triangular prisms are probably the most complicated surface area problems because there is no good formula. So the first thing I have to do is find the area of the base. And the base is what I have 2 of. And if you think about this figure, I have 2 triangles and then I have 3 rectangles. So my triangles are right here, that one in the front, and then I have one identical to it in the back. So I'm first going to find this area right here, okay? So I'm going to call that the front and back triangle. So area of a triangle is 1/2 times the base times the height. Okay, well, the base of that triangle is 6.5. So we have 1/2 times 6.5. And the height is this dashed line here, which is 4.7. So times 4.7. And I'm going to put that into my calculator and find out what I get. So 1/2 I can put in as 0.5 times 6.5 times 4.7. And I get 15.275. Okay? So 15.275. Now keep in mind, I have two sides, the front and the back, that have that same area. Okay? So now let's focus on some other sides. Well, let's look at this rectangle right here that I'm tracing. And I know I'm tracing in gray, so it's kind of hard to see, but, oops. There we go. See if I can fix that. There we go. So I'm looking at this rectangle right here now. Okay? Well, I'm going to call that the left and right because there's one on each side. And I know it's a rectangle. Okay, so area of a rectangle is easy. It's just length times width. Well, my length, let's say, is 8, and my width is 10. So 8 times 10 is 80. So how many sides have that area? Well, 2. There's one on each side. Okay, now there's one more rectangle, and it's the rectangle that the figure is sitting on. So it's the bottom rectangle. Okay, now again, it's a rectangle, so I know area is length times width. So what are the dimensions of the bottom of the figure? Well, 6.5 by 10. So 6.5 times 10 is going to be 65. Now there's only one side that has that area, so I don't double that side. So now to find the surface area, I'm going to add everything together. I'm going to double 15.275. I'm going to double 80. And I'm not going to double 65. So now I'm just going to add all 5 of these sides together to figure out what my surface area is. And if you put this into your calculator, you get 255.55, and then your unit is square meters. Okay, now let's find the surface area of this cylinder. We're going to use 3.14 for pi. So there is a formula for this one. We're going to do 2 times pi times the radius squared, because we have to find the area of the base, and then we have 2 of them, okay? And then we're going to add to that 2 times pi times the radius times the height. How far apart are those 2 circles? So remember, every time I see pi, I'm going to use 3.14, and I just have to figure out what the radius and the height are. So the radius is this 5 inches, and the height is this 18 inches. So we have 2 times 3.14 times 5 squared plus 2 times 3.14 times 5 times 18. Oops, and I ran out of room. Let's see if I can move this a little bit. Okay, so now I'm just going to put this into my calculator. So we have 2 times 3.14 times 5 squared plus 2 times 3.14 times 5 times 18. And when I put all that into my calculator, I get 722.2. So that is my surface area, 722.2. My unit is square inches. Okay, let's move on to topic 8, volume. So there is a general volume formula, and that volume formula is V equals big B times H. So you need to know that big B represents the area of the base, what you have two of, okay? And then the H is how far apart those two bases are. So number 22, Greg is filling a container with sand. How much sand will fit in the container? Well, we've got a rectangular prism, and I know that my base is this rectangle down here, okay? Now, to find the area of that, I would just multiply length times width. And my width, it's labeled up here, is 4 centimeters. That right there is 4, okay? So let's think about this. If volume is big B times H, and I know that big B in this case is going to be length times width, could I just say that volume then is length times width times height? I sure could. So let's label things. We've already labeled our length and our width. That means 21 has to be our height. So we're going to multiply 14 times 4 times 21. And we're going to put that in our calculator and figure out what we get. So 14 times 4 times 21, I get 1,176. So the volume is 1,176 centimeters cubed. Okay, let's look at number 23. Storage locker A is 4 feet wide, 8 feet deep, and has a height of 6 feet. Storage locker B has a volume of 200 cubic feet. Which storage locker is bigger? Okay, well, I've got my 3 dimensions, length, let's go with length, width, height for storage locker A, so I can find the volume. Okay, and think about a locker. It's a rectangular prism, right? So volume for storage locker A is going to be 4 times 8 times 6. And when I put that into my calculator, 4 times 8 times 6, I get 192. So 192 cubic feet. Okay? So this right here is for storage locker A. 192 cubic feet. Now, storage locker B is 200 cubic feet. It tells me that right here. Okay, so which storage locker is bigger? We can see that storage locker B is bigger. Okay, let's move on to the last page. Find the volume of this triangular prism. Well, we know that volume is big B times H. And big B for a triangle is going to be 1/2 times the base of the triangle times the height of the triangle. And then I'm going to multiply that by how far apart the triangles are. So we have 1/2 times the base of the triangle, which is 8, times the height of the triangle, which is 4. And then I'm going to multiply that times 15, how far apart the two triangles are. Okay, so 1/2 times 8, I know is 4. 4 times 4 is 16. So 16 times 15 is what I'm going to put into my calculator, and that's going to tell me the volume. So we have 16 times 15, which is 240. So the volume is 240 cubic centimeters. Okay, last question. 3.14 is the decimal approximation for pi. Or you could write the symbol like that. 3.14 is the decimal approximation for pi. This is the end of your study guide. Good luck on your test tomorrow.